Hello students, then we are solving NCERT class 12 chapter 3 current electricity questions, and student, you can find out link of solution of all questions of this chapter is below inside the description box. Student, also we have also solved questions of SC Verma chapter 32 electric current in conductors. SC Verma, that is necessary for students who are preparing for IIT or NEET, or if anyone having plan in future for preparing IIT or NEET. So the solution of link of all those questions of SC Verma you can also find out here inside the description box, or there is playlist separately for the solution of SC Verma, you can see there. Okay, and so if anyone student is new on this channel, I very request you to subscribe this channel, and let us start today's class. Student, question number 3.13. 3.13. This question is saying the number density of free electrons in a copper conductor estimated in example 3.1 is this. How long does an electron take to drift from one end of wire 3 meter long to its other end? The area of cross section of the wire is 2 into 10 to the minus 6 square meter, and it is carrying a current of 3 ampere. Student, the situation is like this. You have a copper conductor like this. You have a copper conductor. Just suppose that this conductor in turn connected across a source. Okay, so that due to this source a current of value I is flowing through this conductor. Okay, the length of this conductor L and area of cross section is A. Okay, so the question is asking how much time the electrons of this conductor will take to move from one end of wire to another end. Student, what will happen due to flow of this current? Current is flowing in this direction. It means electrons are flowing this direction. Okay. Now, how will you calculate time taken by the electron? If its length is given, so if t is the time taken by electrons to move from one end to another end, it means t equals to L by Vd, where Vd is the drift velocity of electron. Drift velocity is what? It is the average velocity. It is the average velocity with which electrons move inside the conductor. Okay, means we have to mainly calculate the value of drift velocity Vd. So for this we have a relation I equals to NEVDA. I equals to NEVDA. Here I is the current flowing through the conductor, N is the number of electrons in unit volume. In unit volume, number of electrons, since there are a lot of free electrons inside this copper conductor, so N is the value here, is the number of free electrons in unit volume, and its value is given 8.5 into 10 to the power 28 cubic meter. Is the electronic charge having value 1.6 into 10 to the power minus 19 coulomb, which is the drift velocity with that we want to find its value, and A is the area of cross section. Okay, so from here you can write L by Vd. From here you can write Vd equals to I by NEA. And from here you can write NEAL. This NEA will come outside, and there this is I. And now we know the value of all the terms, and so putting these all values, N is the concentration of electrons, 8.5 into 10 to the power 28. Okay, is the electronic charge 1.6 into 10 to the power minus 19. Is the area of cross section, and its value is 2 into 10 to the power minus 6. 2 into 10 to the power minus 6 meter square. And L is the length. Its length is given 3 meter. Okay, and the value of current flowing through it is also given 3 ampere. Now solve this question, it's very easy. Now 3 and 3, this will become cancelled. 8.5 into 3.2 into 10 to the power 3 second. Okay, now and if you solve this 8.5 into 3.2, then you will get this value 27.2 into 10 to the power 3 second. Its answer. This is question number 3.13. We can write this in this way, 2.7 into 10 to the power 4 second. Okay, student. Now we start to solve question number 3.14. It was the easy question, formula based question, you can understand. This question is saying, student, the Earth's surface has a negative surface charge density 10 to the power minus 9 coulomb per meter square. The potential difference of 400 kV between the top of atmosphere and the surface results due to low conductivity of lower atmosphere, okay, in a current of only 1800 ampere over the entire globe. If there were no mechanism of sustaining atmospheric electric field, how much time, if there were no mechanism of sustaining atmospheric electric field, how much time roughly would be required to neutralize the Earth's surface? Okay, thereafter it is saying this never happens in practice because there is a mechanism to replenish electric charges, namely the continual thunderstorms and lightning in different parts of the globe. Radius of Earth is given, having value 6.37 into 10 to the power 6 meter. Okay, so student, what is this question? This question is saying 3.14. Suppose this is your Earth. Okay, now, and the question is saying the Earth's surface has negative surface charge density, which is normally we represent by sigma, and its value is given. Sigma is 10 to the power minus 9 coulomb per meter square. Okay, this you can write in this way: 10 to the power minus 9 coulomb per meter square, means in per unit area 1 meter square there is a charge of 10 to the power minus 9 coulomb. Okay, this negative charge Earth's surface has, this is given. Further, the question is saying, we know that large number of atmospheric level surrounding the Earth's surface remains. Okay, so let this is the top atmospheric level, and there is a potential difference between this top atmospheric level and Earth's surface. Let this is delta V, and its value is given. Delta V is 400 kV. Okay, then the question is saying, due to this potential difference, continuously current flow towards the Earth's surface like this. Obviously this will happen surrounding the Earth's surface from all sides, like this, from all sides. A current of value I, and its value is given 1800 ampere. 1800 ampere, this current 1800 ampere means, a student, you can write this in this way also in another unit: 1800 coulomb per second. Okay, means in every second, in 1 second, 1800 coulomb charges are flowing towards the Earth's surface due to this potential difference. Okay, then student, what will happen, since Earth has already excess electrons, negative electrons having negative surface charge density is given, and positive charges are flowing, current is flowing, means positive charges are flowing towards the Earth's surface having value 1800 coulomb per second. So finally this negative charge of Earth's surface will start to neutralize due to flowing of this positive charge, due to flowing of this current. So the question is asking that how much time it will take to completely neutralize the Earth's surface. Okay, student, for this we will have to calculate the total charge present on the Earth's surface. Let the total charge is capital Q, total charge. This we can easily find. Okay, if R is the radius of Earth's surface, then the total charge of Earth's surface, Q is what? Total charge on Earth's surface. Its value will be sigma into 4 pi r square. 4 pi r square. Why? Because Earth is a spherical surface, so its surface area will be, if radius is r, capital R, so its surface area will be 4 pi r square, and since surface charge density is sigma, so total charge will become sigma into 4 pi r square. Sigma is the charge per unit area and the total area is this, so multiply total area with the charge of unit area, you will get the total charge. Okay, now also we have also a relation I equals to Q by T. From here you can write T equals to Q by I. Okay, student, and now you can find the time taken. T is the time taken. that we have to calculate, time taken to neutralize. Okay, so charge we are knowing, current we are knowing, time you can calculate. Charge is sigma into 4 pi r square. I is the current. Sigma is what? Its value is given 10 to the power minus 9 into 4 into pi having value 3.14. Radius is given 6.37 into 10 to the power into 10 to the power 6 whole square divided by I. Its value is given 1800, and simply solve this. When we will solve it, this is 4 into 3.14 into 6.37 into 6.37 equals to this divided by 1800 equals to 0.283 and into 10 to the power 3, and this becomes finally 283 seconds. This is your final answer. Means 283 seconds this time finally will take to completely neutralize the earth's surface due to flow of this current. Okay, student. Question, student, there is also another question. In fact, no, this is not a question, this is just written here that in fact practically it does not happen so, because what happens exactly, due to some phenomena like thunderstorms and lightning in different parts of earth's surface, there is replenish of electrons. Replenish means refilling of electrons also occurs, and that's why the charge on earth's surface completely not neutralized. Okay, student, so I think you should not have any confusion, and we meet in next class with solution of next questions. Thank you.